Hello everyone. So we're going to do a little bit of review today for the upcoming test, and if you missed anything in class, you need to get caught up on anything that we've done so far, this is just going to be a review for that and a way for you to make sure that you're up to speed and that you know everything that you're responsible for knowing for the test. Okay, so we're going to start with our periodic table here. So a couple things we have done already is we have labeled the groups. So remember, our groups run from left to right. Group 1, Group 2, Group 3, Group 4, and so on. Our periods run from top to bottom, period 1, period 2, period 3, period 4. We also have added some notes on here. So up here, I put a little square around this box so that you don't have to memorize this. You can use this periodic table as a reference on the test. So it's a way for you not to have to remember these things, but to be able to use this as a resource. So the atomic number is going to tell you how many protons and how many electrons are in an element. To calculate neutrons, this is the one where you have to do the subtraction. So you take the atomic mass, which is the number down here, and you subtract the number of protons, and that will give you neutrons. Okay, protons, electrons, neutrons. This is kind of a critical first step to be able to move on to the rest of what we're going to be doing. Okay, all right, so looking at an element, and I'm going to use carbon as an example because this is the biggest one and the easiest to see. So if you were asked what is the atomic number of carbon, very simple. It's right here. There's an arrow pointing to it. Atomic number would be 6. So for any of the other elements, it's the same thing. The number on the top is going to represent the atomic number. Okay. If you were asked for the chemical symbol of carbon, okay, here's the name, carbon. It's a capital C. So remember, anytime you have one single letter representing an element, it's going to be capitalized. And when you have two, okay, like chromium, we have a capital C and a lowercase r. That's important. Capital C, capital R is something different than capital C, lowercase r. All right, so to calculate protons, neutrons, and electrons. Protons and electrons, remember, comes right from here. Calculating neutrons, we take the atomic mass, 12, and we subtract the number of protons, 6. 12 minus 6 is 6. So that would give us 6 protons, 6 electrons, and 6 neutrons for carbon. Okay, so atomic structure. We took some notes on this in class, so you should already have this. So atomic structure. So we did this drawing and we did this drawing. This drawing over here is the Bohr model. These both represent the same thing, really. We have a nucleus in the center, a nucleus in the center. The rings surrounding are the electron clouds. Okay? Within every atom, we have protons, neutrons, and electrons. Protons always have a positive charge, so that's written as P positive. Electrons have a negative charge, written as E minus, and neutrons have a neutral charge, N with the circle here. Okay? This is going to be important as well. So remember when we were drawing our Bohr models, what did we put in the nucleus, in the center each time? Protons and neutrons are both located in the nucleus. The electrons are within the electron cloud, the rings around the outside. Okay? All right, I'm going to do one more example for you here. So let's do mercury. So first thing we need to do is find mercury on our periodic table. Okay, once we find mercury, then we can use the formula that's up here to give us protons, neutrons, and electrons. So again, remember we're using the little things that are already up here to help us with that. We don't need to refigure this out every time. So having your periodic table with you is going to be important. Okay, so Mercury. Where's Mercury? Sure, I'm looking right past it. Ah, here it is. Okay, so Mercury is Hg. So chemical symbol would be capital H, lowercase g. Number of protons in Mercury, so I have 80 as my atomic number. So that means I have 80 protons and I have 80 electrons. How do I know that? 80 and 80 because atomic number is the same as protons and electrons. Protons and electrons, 80, 80. Number of neutrons. Now I have to take the atomic mass, 201. I take my 201 and I subtract from that 80. And that is going to give me my number of neutrons. Okay, Bohr models. We did some notes and some practicing of Bohr models together in class. Okay, Bohr models can consist of a nucleus containing protons and neutrons and electron energy levels, also called shells. First level holds 2, second level holds 8, third level holds 18, and fourth level holds 32. Maximum means the highest amount, so an atom can have less than the maximum amount, but it cannot have more than the maximum amount. Okay, so we have magnesium here, and this is the one we did together in class as an example. So the first thing we had to do was determine how many protons, neutrons, and electrons before we could draw the Bohr model. Okay, so over here, atomic number for magnesium. So I'm looking on my periodic table, its atomic number is 12. Atomic number is 12. Okay, atomic number is 12, meaning 12 protons, 12 electrons. I have to calculate my neutrons, so now I need the atomic mass, which is 24. So I take 24 and I subtract from that the number of protons, which was 12, and that gives me 12 neutrons. So now I have 12, 12, and 12. So the protons and the neutrons, remember those are in the nucleus. Protons and neutrons are in the nucleus. So on the inside of my Bohr model, I write P plus, which represents protons, equals 12, and N, neutrons, also equals 12. And then my electrons, I have 12 electrons. So now I have to place them within the energy levels, or the shells. So remember, energy level 1 holds 2, maximum of 2. I need a total of 12. So I place, here's energy level 1, 1, 2. That's all it holds. I can't put any more on energy level 1. Energy level 2 holds a maximum of 8. So I need 12. I only have 2 so far, so I need 10 more. So this will only hold 8, so I can't put the rest of them on energy level 2. 1, 2, 3, 4, 5, 6, 7, 8. So now I have 2 plus 8, which gives me 10. I need 12, so I need 2 more. So on my third energy level, 1, 2. So now if I counted up all these dots, and you want to make sure you do that, double check by counting your dots, and make sure if you have 12 electrons, you should have 12 dots on there. Okay, that's the Bohr model. All right, the next thing that I want to talk about is Lewis dot structures. So remember, for a Lewis dot structure, all we did, so let's use magnesium again. So I have to find the chemical symbol, which is Mg. Oh, sorry, that's manganese. No, that's magnesium. Mg. So I take and I just write my chemical symbol, Mg. And then I need to figure out, before I can draw my Lewis dot structure, how many valence electrons magnesium has. So if I go back to this, we already drew the Bohr model, and our valence electrons, remember our valence electrons are how many electrons are on the outermost shell. So for magnesium, this is the outermost shell, and I have 1, 2. So that tells me that magnesium has 2 valence electrons. 2 valence electrons. So to draw my Bohr model, or my Lewis dot structure, I use dots and I put them, so imagine you have an invisible line, a box around this. This is invisible, that's why I'm making it with dots, or with lines. So my dots would represent how many valence electrons. Since magnesium has 2 valence electrons, I would only need 2 dots. So the dots can go on any one of these lines. You don't want them in the corners. You don't want to make a circle around it. Okay, imagine there's an imaginary box. On any of these lines, you can put your 2 dots. Okay, 2 valence electrons, 1, 2. So notice there's a difference with magnesium between electrons and valence electrons. Magnesium has a total of 12 electrons. If I count up all these dots, there's 12 of them. But valence electrons are only the ones on the outermost shell, which in this case is 2. Okay, so I drew for my Lewis dot structure my 2 dots. Okay, so that is kind of the things that you're going to be responsible for knowing for the upcoming check-in quiz. If you need help, have questions about any of this, please reach out. But this was just kind of a brief review of all of the skills that you're going to need to know.